Good evening, everybody. Welcome to While True Learn. My name is Jeff. You can call me Jeff. I just want to say, hey, Gareth. Thanks for claiming first, Nutmeg. So this game I thought was, it was free on Epic almost a year ago, I think, and all the wrong stuff here. And I thought it was a game to teach you programming, and I pulled it up to see if it was a game my son might enjoy the other day, and realized that it's actually a game that's supposed to teach you the concepts of machine learning. So it's not going to teach you how to program just like the basics, but it's to teach you the high level concepts. So it's meant to be educational, but it's more of just a problem solving type of game. That also teaches you machine learning. I guess we'll get into it. Yeah, choose checkpoint tutorial. I think you'll like the story too, if it goes into it anyway. To become a programmer, you must master the art of turning the computer on. Is it plugged in? Does it have power? Press and hold the flashing triangle and drag to connect the power outlet with your PC and keyboard. When it's done, press power button that will appear in the upper right part of the screen. Congratulations, you're almost a programmer now. We'll drag that to here, push power. Do I have to do it for everything? You need to plug in the hardware to start working. The cat. Oh, okay. That should do it. Time to cross the fingers and turn the power on. I actually have no idea what to expect really from this game. I haven't tried it yet. Computer is on. One more step to be a programmer. Just one. One more step. All right, so we're a programmer. Working the midnight hours. Oh no, there's a bug. I'll go get some more coffee. Here. I guess I'll go get some coffee. Meanwhile, the cat comes in, starts tippy-tapping on the keyboard, as cats do. The build passed. Cat's like, yeah, dude. Meow. Hey, what did you do? Did you do that? Holy zeros, if only I could understand what this cat has to say. Meow. I guess we'll have to find out a way to recognize your speech. Meow. Goal. Cat speech recognition to-do list. Google it on Cat Overflow. And there we are on Cat Overflow. Hey, Wally. Good evening. My nickname on Cat Overflow. How to recognize animal speech. Recognizing animal speech? Hey everyone, can you believe my cat? That little devil has debugged my code. Again. He definitely has something to say, so I decided to make some sort of system, algorithm, which would help me understand him. Give me advice, wish me luck maybe. P.S. I'm not insane, my mom had me tested. I can tap F5. Cat Overflow, yeah. By the way... Dr. Coder, don't rush ahead of yourself. Making a device that would be able to detect the cat would be a nice start. You can work with video, sounds, etc. when the time is right. Hey, a couple of days ago I've been reading about how expert system can be applied for detecting animals and writing chatbots. The newspaper was called Deep News. I'll be sending you my copies once I'm done with them. Welcome to your workspace. This is where, oh, the blinking. All right. Well, thanks for the lurk at least, Wally. And welcome to your workspace. This is where programming magic and bugs, mostly bugs, is born. To begin, drag an expert system node from the list on the right. So, expert system. Then drag the connection line from the starting node on the left to expert system node on the right. If you want to delete the connection, place your mouse over the line and press the right mouse button. All right, right click to delete. So click. Cool. Also undo. What's this do? Red, else divide. So we're going to try and detect photos with cats and photos without cats. Click test run to see if the scheme works properly. So red comes in, red goes out, blue goes down here. Okay. Supposed to get 8 of each, I guess. Ta-da! Run complete. Success! Final result. Star. I don't know if that's a gold star or a bronze medal. Time spent, 21 seconds out of 26. So you gotta try to be efficient. Hey, again. I've tried that expert system and it hardly makes any sense. Squares are floating from left to right. Is that what the fuss is all about? Machine learning? Are you guys actually working there? This is called visual programming, my fellow dude. Yes, this is how it's supposed to work. The expert system analyzes your data input from the camera and checks if there's a cat on them. No, it's not what machine learning is all about. It will get hardcore soon enough. Well, I'm not very good at it yet, apparently. When do I actually start building a cat translator? Don't rush it, my friend. You gotta master your machine learning ninja skills first. I'm working as a freelancer and have the amount of contracts is crazy. I'll forward you some jobs I don't have time for. It'll help you get on your feet and earn some cat bucks as well. Check your mail below. Check your mail now. P.S. You're still paying for the service, though. Okay. Oh, there's another message. Hey, call me Jeff at cat.meow. Noob advice. There's an auto help for each new technology. Very convenient. I've turned it on for you now. No need to thank me. But you probably want to change your password. My cat talks 1, 2, 3 is pretty obvious. Alright, so we have a task tree. Behold the task tree. This is the map of your progression in the game. Vertical progression stands for story quests. Horizontal branches are optional. Icon colors stand for different types of machine learning text used in respective tasks. Sounds pretty simple, or so we hope. Applicants. So 350 cat bucks. Good day, we're from a public school. Summer exams have ended. The results are attached to the letter. Could you process them and predict which of the students will be able to enter the MIT? Startups private. Okay. Proceed. See these colorful geometric shapes? They represent various kinds of data, numbers, letters, elements of images. In the modern world, everything can be turned into data, and machine learning is all about sorting and interpreting data. Long story short, your goal in the game is to transfer data from the left part of the screen to the right. These bars show the minimum amount of data that needs to be processed to complete the task. That's a lot like the cat pictures we did. So, expert system? So, we don't want it to be red up here, we want yellow. Else, everything else would come down this way, so blue would come this way. Just connect them up. Is that like the cost, I guess? All right, test run. So it looks like it's working all right. Release the program to complete the task. I'd be interested in reading the rest of this. Outputs, occupancy 9 out of 8, 8 out of 8. Okay. First, oh. Couldn't see the achievement that popped up. So Cat Cash Bank, project released. So I got 350, but it cost, that must be the server cost here, 42 cat bucks at cash. So I made 308. Nice. Oh, we're going up. I see. Cat overflow. Okay, so cat speech recognition system, we're 8% of the way there. Recognizing cat on pictures, 42%. Task type, almost machine learning, is purple. All right, errors in DB. Another 350. Hello, we have some errors in our questionnaires data. We can't solve the problem by ourselves. Can you please fix it? Okay. Of metals. Your efficiency is measured not just in money, but with metals too. Metals influence your story progression while boosting your self-esteem at the same time. To get a medal, your scheme has to meet the respective time and nodes limits. You can improve your results later on. Trash can. This node destroys elements. Important detail. No matter how many trash cans you place, they will count for one node in the node's limit. Okay, so basically they're free. Only costs 1. In the real world, real data sets have lots of errors. Filtering out errors is a very important skill for all data scientists. Learn how it works. Warning! Maths, integrals, derivatives, and other scientific words inside. So this would be... I did check, there was a button on the main screen that had, go learn this stuff for real, and it sent you to... they had articles and websites and YouTube playlists and all kinds of stuff to link out of this game out to learning materials in the real world. So I bet that goes somewhere to maybe a Wikipedia article or something. All right, so we only want the red and yellow. We don't have an output destination for blue, so we'll use a trash can for that. So our expert system, basically the blues are the errors. That means we want to filter for blue, send all the blues to the trash can, send everything else to our output. All right. There's 10 of each. So by the time we hit 15, we should hopefully be under the 29 seconds there. Test run. Without blue. I like how it measures our accuracy over here too. Here's our cost is 2 cat bucks per second. All right, success. Money spent, 27.9, so we were just under time. And we made some money. Sweet. Errors in DB number 2. Ooh, coming up next is basic machine learning. Private. All right, so this is the Spanish school again. Hello, it's us again. We found some new types of errors made by our users. Please update your program, it'll be easier if you just use the previous version of the code. Okay, let's private. History of expert systems. Ooh. Random machine learning facts at cat.meow. History of expert systems. 1965 can be considered a starting point for the work on creating expert systems. That year, scientists of Stanford Research Institute, Edward Feigenbaum and Bruce Buchanan, teamed up with Nobel laureate Joshua Lederberg and began working on a computer system designed to determine the molecular structure of chemical compounds. It is interesting. I'm going to go right out now and say I am going to mispronounce a lot of stuff and names. I apologize. Oh, deep news. Non-neural artificial intelligence. Mankind has always been trying to create an artificial intelligence. Before the invention of neural networks, people used expert systems. An expert system is a deterministic algorithm which reproduces decisions of a real person. In this example, an example of this is Eliza, the very first chatbot in the world. It was created in 1966 and talked with a patient using questions similar to real psychotherapists. It worked horribly. Hello, I am Eliza. Hi, Eliza. How are you today? What would you like to discuss? All right. So check this out. Custom nodes are special nodes containing your previously designed schemas. Nice. Press on the middle tab to switch to custom nodes list. Okay. Okay, so there's our without blue is what we used last time. So we can drag the custom node, sorting the color red, to the workspace. If you want to modify the scheme inside the custom node, double right click on it, or press the down arrow icon on it. Drag that in. So we want, before we were filtering out just the blue, now we just want the red. That's it. Then just trash the rest. What's this do? Red to the top. Everything else to the bottom. Okay. I go back this way. Okay. So red, else. That is a good name, I guess. Red here, else there. Test it. So blue should go down, red should go up, yellow should go down. It looks like we'll start building up a whole library of components to put together as we go here. Launch complete. Success. Gold medal. Okay. We did it. Yay. Making some Meow. Decision trees. Eliza, world's first chatbot. So cute. Illuminati origins. All right, so we'll do decision trees now, which is basic machine learning. By color code there. Cat overflow. Hey, is there any way to detect the cat without using expert systems? It works for texts, but with pictures, not so much. Furthermore, that cat just won't sit still. That it does not. Try decision trees then. Those are like expert systems, but on steroids. Once you feel comfortable around them, try SIFT. S-I-F-T. This little devil is way more effective with pictures. Also works nicely when paired with other algorithms. Or you can use nails or glue or something. Come on, it's just a cat. It won't fight you back. I joke. Please don't use anything I mention on an actual cat. So processing time. Different nodes have different processing rates. This parameter will influence efficiency of your schemes. Icons on the right indicate the amount of time required for a node to process one element of data. Okay. Decision tree. Color. This node compares output parameters, the sockets, with an element's color. The element color is equal to only one socket's color. The element moves to that socket. If an element's color satisfies both conditions, or none of them, it goes to a random socket. Interesting. So red will always come out here, and blue will always come out here, but anything else could come out either. In the real world, decision tree is one of the basic machine learning algorithms. Each tree knows a limited number of classes. For each element, the tree asks some questions and chooses the class most similar to the element. So if we're taking in 3 colors, oh, we could just do one decision tree then. Because we can have yellow and red here, and we can have yellow and blue here. So red has to go this way, blue has to go this way, yellow we don't care, can go either way. I was thinking we'd have to put an expert afterward to filter again, but guess not. So that should be that. The decision tree is a lot quicker, you can tell. Cool. Now on to things like the Illuminati origins. Actually, I want to do some of these side branches. So decision tree equals smart tree. Optimization. Hi, it's us again. We hope it's our last request for you. We've changed our database system. Can you update your code one last time? We need it to work faster. Okay, we got another private message here. Who invented the decision tree? Decision tree is one of the automatic data analysis methods. The first ideas of creating decision trees date back to the works of Hovland and Hunt in the late 50s of the 20th century. However, the fundamental work that gave impetus to the development of this direction was a book named Hunt, Marin, and Stone Experiments in Induction, published in 1966. So let's take a look at this. We changed it. Can you update it to work faster? Faster, better, stronger. To decrease and increase speed, click a button on the screen or use the arrows A and D. Press space to pause. That's just to make the simulation run faster. They wanted, before we used an expert system, which takes a whole second, where if we did something like a decision tree, we could do much less time. So they only want red. If we do red here, some yellow will come out. So what if we do 2 decision trees and a trash can? Say any yellow that still makes it through, we can send to a trash can. These are supposed to only count as one node. Even I can put as many trash cans as I want, and they only count as one. So all blue will come out this way, All red will come out this way. Yellow could be on either one. Yellow should all come out this way. Red should come out this way. And that should work in 0.6 seconds per node rather than 1 whole second. So it's an optimization. Red, only red fast. You can see red and yellow both coming this way. All the yellow's getting sent to the trash can. Nice. So it only took 13.7 seconds. Should be happy about that. Oh, look at that. I think we saved money on our cat cloud there. I didn't notice how big the reward was on that one. Now let's take a look at MedX. Greetings! Our company is manufacturing all organic, natural painkillers. They are used to decrease suffering, mood improvement. Are we decreasing mood improvement? And coping with eating disorders. That's a weird phrasing. But there's a lot of that in this game. Known side effects, including dilated pupils, diarrhea, physical and mental addiction, are caused by the human factor. From time to time, our workers pick the wrong plants because they look like medical herbs. We'd like you to design an algorithm that would sort herbs by petal's color. Okay. So we have 3 different inputs. Those are weird numbers, but how do I want to go about this? Red, green, green, blue, red, green. So this would split out red and blue right away. And some yellow would come this way, some yellow would come this way. Can I send this also this way? How would I ensure that I get 15 here and 19 here? If they're random. First of all, can I connect that to 2 different things? I can't. So if it matches both, it's supposed to send it at random either way. Can I reorder these? Be nice, just to not have to cross them over. So red. Actually, delete that one. So red and blue. This will split these randomly. And blue can just go straight through. So yellow will get split randomly between these. It's the randomness I don't like. I like deterministic stuff better. A little bit faster. So we're down to a silver medal. I wonder why. Nope. I didn't see what caused our metal to go down to a silver. Error. Stack overflow? I keep trying to get out of the way of that. Alright, project released. Alright, we can't do this one until we do chicken escape. Let's back out of here. Here's our desk. Got the cat. Seabay. Buy some stuff. Entourage. Random forest. Says stochastic. Isolation forest. Cat skins. Meow. Meow. Only if you find the way. Get a cat. Get a cat. You can get another cat? Oh. That took me to a website. Anyway, I could get the Viking helmet for my cat. I could get an aloe plant. Does nothing. Has TESV. Skyrim. The Elder Scrolls 5 Skyrim installed. Mandatory for purchase. Beauty and Harmony. Hide purchased stuff. So, there's our aloe plant over here. It's day 1, week 1. Alright, let's check out Illuminati Origins. Good day. I study ancient manuscripts and books in order to figure out the true story behind the Illuminati Secret Society. I need to recognize all the triangular shapes in these documents to solve the puzzle. Could you design a program that would do that for me? You betcha. Oh, the Sift node. Cool. This node compares shapes. If an element's shape matches the designated shape, said element goes to the top socket. Everything else goes to the bottom. So it's kind of like an expert system, but it's slower. So in the real world, Sift, scale invariant feature transform. It's one of the most powerful non-neural algorithms for detecting features on pictures, which is essential for image recognition. Sift is very fast and is capable of recognizing simple objects and patterns. Cool. You can go to how it actually works in the real world, I say. So we have circle, square, triangle, 42 of those. It's the answer, you guys. It's the Illuminati. All right. Sift, and a trash can. We want the triangles and nothing else. Oh. Almost there. Cool. Gold medal. Release it. Making the cat bucks. Oh, startup. Task type, startup. So we can work for a startup. Working for the man. Feels too easy, boring, or soul-sucking? Aim for the sky and become a CTO of a startup. In the world of savage market laws, it's either sink or swim. Will you get rich or bite the dust? It's worth trying anyway. All right, so we could do some more side quests. We could do a startup, or we could move on to almost machine learning. Let's do these couple side quests and then try the startup. Chicken escape. Oh, we got a private message. A letter from Mom and Dad. Hello, dear. We remember how you cherish your financial independence, but come on, your birthday is just around the corner. Be a good kid and take this money and buy yourself something nice, will you? We love you very much and we miss you. P.S. Do not forget to put a hat on. It's very cold outside. They sent us money. Nice. Right, back to Chicken Escape. Hi there, my name is Sarah. I own a small technology farm. Our distributors demand supplies of eggs of different kinds, and it takes a lot of time to sort them manually. That's why we've decided to automate the process. We have all the data about eggs parameters, but we need an algorithm which will work without human assistance and with high accuracy. So we're just sorting the shapes. It's like a sift and a sift. So circles go to the top. Everything else comes here to get sorted into squares and triangles. No trash. I like how the longer ones make it look like it goes faster. They're like, Meow. On triangle. Haha. Thank you, pirouetting worm. And hey. Launch complete. Silver medal again. Could have used up to 9. I wonder why I keep getting silver medals on these. I don't know what I would have done different in that case. Alright, crowd psychology. Good day. Fightman group? Fightman? Our company is making a research on crowd psychology. We need an algorithm which would be capable of defining a person's type based on certain behavior patterns. This way we will be able to quickly identify dangerous individuals in the crowd and prevent unpleasant accidents. We have identified the parameters to work with, but we need an experienced developer to write the algorithm. That sounds dangerous. Dr. Doof! What's going on, man? Oh, Atrio. I saw you were streaming that earlier, but I didn't see. I feel like I saw that when it was on Steam or something, but I completely missed and forget what it was about. So here we're sorting colors and shapes. Ha. You played this? Watch her learn? Yeah, so far it seems like there's really only straightforward ways to solve it, but this one, we're sorting colors and shapes now. So I think sorting colors would be easiest. So if we want some red squares here and some red squares here. Ugh. See, I only have circles here. We don't have any down here, I mean. We don't have any triangles up here. I'm gonna keep in mind this as a side quest and not spend too much time on it. See, so all the circles should come here. And then we only want red and blue ones. Yes, this is the one where we're trying to figure out how to talk to our cat because our cat solved a programming problem that we were banging our head on. And so we're getting on Cat Overflow to learn how to do machine learning. All the circles can come here. Everything else can come down here. Some squares we want to come up here. So that sounds like a decision tree because it'll send stuff both ways. For instance, we want blue up here and we want any yellow down here. There's an any? Oh. But we wouldn't mind red either way. I can zoom in and out. Good. I was just wondering. It's going to be busy in here. It's all circles. We only want red or blue. What do we have over here? Red and blue separate out. Yeah. Only red. Next. Only triangles. Ooh. That would be pretty good. Only triangles fast. Using sift. When we go back. See, that could be good for circle, square, triangle, sift. Get rid of these. So if we... all the triangles should go down here. And then we only want yellow. I guess we got rid of the expert system. Alright, so triangles down here. If we do sort out triangles, that would leave squares and circles. All the circles should go up. Well, this will only send through triangles. Everything else is getting trashed. So I don't think I want to use that. But we could sort our shapes out, at least. So circles come out the top, everything else will come out the bottom. And here we could have squares coming out the top and triangles here. Some squares are going to go here, some squares are going to go here based on the color. Down here we have visual programming. Down here we have red and yellow. So things that match red would come out the top, things that match blue would come out the bottom. Any yellow would be random. I don't like it. I think I'll come back to this one instead of spending a bunch of time on it. Let's go check out the... oh, we have some new items on eBay. You get a cactus. Protects from radiation. And cat marine from Banhammer. Hardware. Ooh, sockets. Processing queue. Tambourine. Increased data transfer speed by 1%. And Rentium. Increases nodes work speed. Okay. Let's do some upgrades. Or FPS for the FPS god. Yeah, and let's do some... that's 40,000. That's not a reference to anything. Okay, Let's get a tambourine and a... Sure. Upgrade our hardware there. All right, let's go check out what the startup looks like. Mama Smith's Pizza Shack. Hello! We're honored to invite you to join our startup. World's first AI-controlled pizza place. But our fingers are always stained with flour and we can't really code because of that. Help us write and implement an algorithm that would be capable to separate orders for round pizza from orders for square-shaped pizza. Let's feed the people and become rich. Sure. We need more gold. A scheme created while working for a startup does not differ from any other, but there is no solution to startups. A scheme just works better or worse, and your future profits depend on its quality. Okay. So here's what I was saying. Some of these seem really straightforward. And it's like, how would I improve on this? It'll send 2 circles this way, and everything else will come down this way. Program seems to be working fine. Further testing won't affect your results in this startup. Feel free to stop testing now. Okay. You're trying to design an AI-controlled pizza place that serves pizza in round and square shapes. Yes, I heard. The scheme you're designing is the brain of the pizza robot. The brain! It sorts orders by shape of pizza that your clients order. Yes. These are the users of your startup, in this case, your pizza restaurant. They've heard of a new amazing place in town and now they want to grab a slice. These are your clients' orders. The millennials don't care too much about toppings, only shape matters. Mind the accuracy. If a client gets a pizza they've ordered, they will pay you money and tell their friends about your place. If a client doesn't get what they want, they refuse to pay and don't expect them to return with friends. Okay? One more thing, clients don't like waiting in queues and they will leave with no hesitation. If your scheme is working slowly, the waiting line will get longer. The market is constantly changing, so pay attention to what's going on and experiment with your schemes. Now it's time to launch your first startup. Hooray! So yes, circles, squares, release. This action deploys the code to the servers. From this moment, the startup will work automatically. Okay. I think I like the extra confirmation, so I'll leave it for now. All right, startups. This table is your principal source of information about your startups. Press next day button to proceed. Okay. So we could change it by patching income users hype. Next day. When you switch to the next day, you get the money you've earned or lost, depending on how many users' requests were processed by your scheme. Okay. Press the next day again. Okay. Hey, look, your users seem to like what your scheme is doing. They're even inviting friends. The cash is flowing. Next day. When the hype icon is green, that means your startup is all over the news. Expect lots of new users. Do I have to come click this all the time? Or will that kind of... Mama Smith's Pizza Shack. So I got a reward. So I get paid weekly, I guess. What does this button do? Is this my exit? Cash out? Anyway, I think what'll happen is as we solve puzzles... I love the hat. As we solve puzzles, this will increase anyway. I wasn't expecting the thunder. So as we solve puzzles, the days will go on and we'll make money anyway. So that's in progress. We'll come back to crowd psychology another time. All right, 18% of the way there on cat speech recognition systems. We've reached the end of the epoch. Click on one of the banners to proceed further in the story. Okay. Eliza, first chatbot. Cats, biology, iRobot. Cat mail. The Nyan cat. Oh, we got a camera and a TV. This should definitely work. Eureka! It's a cat. Cat. Meow. What happened? Meow. Yes, meow. Repeat, please. Meow. The cat has been detected. The dawn of civilization. Goal, learn how to detect the cat in the pictures. Okay, so neural networks. Rosenblatt perception. Animal emotions recognition. Hey, so I've managed to make my computer detect the cat, but that beast is a complicated soul. It definitely has more to tell. Maybe it's time to go next level and start recognizing emotions. Ever heard of perceptrons? They were invented in the 60s to recognize written text. Everyone knows that everything invented in the 60s is awesome by default. The double helix, rock and roll, lava lamps. Also, you can maybe switch to dogs instead of cats. Decision trees worked like a magic for my Pluto. You can also hit the store and get that random forest node. Forest is more effective than just one tree, you know. Error rate. And now for something completely different. Perceptrons can actually learn and improve. Bad news, they will also make a ton of errors on the way. The percentage of errors is shown on this icon. So this one's only 75% accurate. No, 25% accurate. 75% wrong. Use training mode to teach perceptrons and decrease the amount of errors, okay? Aha. In the game. Circle, square, triangle. Good. Circle, square, triangle.
They call me
Good.
Jeff. They call
Class
me Jeff.
deviant.
They call me Jeff. They call me Jeff. That's not my name. My name is Jeff.
How you doing, Glass? Thank you so much for the subscription. How are you doing tonight? It's called While True, Learn. And it's a game that teaches the concepts of machine learning without being programming specific. So you solve puzzles by connecting nodes in this visual programming sort of way. And our ultimate goal is to learn to understand our cat. Apparently our cat is a better programmer than us. We just need to learn from it, and we need to figure out how to talk to it first. So we're just starting to learn about neural networks with perceptrons. So while trying to predict, in training mode, perceptron reduces the amount of errors while trying to predict the shape of elements. In the test run, perceptron only predicts shapes. Amazeballs. In the real world, Rosenblatt's perceptron used in Mark 1, this perceptron could recognize only simple linear dependencies. You can see in the background the neural network shape here. But it was enough to recognize English letters. And that's one of the things I like about this is it has like links to real world stuff that you can go and learn about these things. So it's not I mean, the in-game stuff is fake, but it's also the real concepts, and then you can go see what, if something interests you, you go learn more about it. So, a single node. So this perceptron is going to get only a quarter of the answers right. So we have to train it. Circles go here, squares go here, and triangles go here. So I said we do training, and we try to get above 60% accuracy, I guess. Occupancy, accuracy. So we'll do training, and it should get smarter as it goes. You can see it's getting better as it goes. There we go. It says 60%. The nodes on the field have reached their minimum marginal error. There's nothing more you can teach them. Okay. So we let it run, and kind of what it didn't show, I guess, is that it was getting feedback. So if it sent the wrong thing this way, it would get feedback and it would learn from that so that its accuracy would increase. Now it's only failing 20% of the time. So we'll do a test run. And like there, it sent a circle to the wrong one. So the accuracy is going down a little bit, but it was above the threshold. So we're good. All about hype. Time is passing by and the market changes. When the hype icon is yellow, it means that your target audience is already aware of your startup. Don't expect many new users at this point. We'll push the next day button. When the hype icon is gray, that means that you've satisfied your target audience. Users are starting to leave. Watch your earnings carefully. When the number becomes red, it's time to cash out. So when the income starts going red. Okay. Is this going red? Okay, so that's been another week. Okay, time to cash out. Today your shares cost 2,065 cat bucks. Are you sure you want to sell them and leave the startup? Yep, sell. Cool. So I think we made money on that. Cash out there. We cashed out. We exited. Let's see what's on eBay. We get a fade haircut. Back propaganda poster. Data scientists of the world unite. There's no new hardware we can get yet. And this all is locked. They did mention the random forest, but I think that comes later. Oh, because propagation and back propagation. I think that's a term in machine learning. I should have led with I am a programmer. I'm not a machine learning. I know nothing about that really. And sure, let's get the poster for fun. So we got our poster, our tambourine. There's all the other stuff we had. Cat. Cactus instead of our, I guess we swapped that out for the aloe. We had an aloe plant there before. All right, so what else can we learn? Let's do some side quests, maybe. Dairy products. Perceptrons, good for pictures, and Grandpa probably used it. Dairy products manufacturer from fresh milk at Cat. Yeah. Hello, my name is Sam. I own a dairy products factory. My dream is to make the very best goods on the market, and that's impossible without high accuracy in fermentation processes. All right, off with the fancy words. I want a program that would judge the quality of a product by its ingredients. We often make mistakes when doing it manually, and a lot of our products never leave the factory since we mark them as defective. We have the data, but we need the algorithm. So perceptrons it is. So we want some circles to come here and every thing to come here. I'm not sure I get it. Can I hook all of these up to the same one? Can. But I guess we want 2 of them. So that some circles come here and everything else goes there. Let's delete those. So do I really want 2 of these? So the input can only go to one thing. I can't also connect it to a second perceptron. So if we have everything coming out here, and I could use, see, this sorts everything out. That's what we already had. Or that's what we would be getting here. But this is already trained. So do I want that instead? So an already trained perceptron sorter. And then we want do we want all of those to go back into these side quests, man? So everything goes here, but also circles there. So what would happen if I just hooked these up like this? How would I send some things down here? Oh. What if I send these 2 this way? And then send, so a lot of circles will go this way. Everything else will come this way. We want all those circles to come here and these to go here. Something like that. That work? So let's swap these. That's not any better. Okay. Would that work? Wrong. Or no, actually, that's right. This one was wrong. All right, so this one's 20% better, or only 20%. Wrong 20% of the time. This one's getting better, but the accuracy down here is still bad. The nodes on the field have reached their... Really? Minimum margin of error? There's nothing where you can teach them. Ah. So if I test it now, will it work? We're not getting any circles to the lower one, though. There comes a circle. Hmm. Okay. Again, this was a side quest. I think we should proceed. Come back to this another time. We could do text recognition, or we could do RL0. Ooh, self-driving car startup that way. Reinforcement learning. Hello, not a cat at meow.cat. Instead of cat.meow, this sounds like spam. Hello, we is a society of peoples who love cats. We wants our cats to has all of the best. We wants cats to drive cars with no humans inside. But cats have no hands, cats has paws. Can yous make a car that self-drive? Yours, Dr. Meow W. Cat's human person. P.S. Please excuse our grammar. We are not cats, we are humans, but we can't type well because we has paws and no hands. Terrible car accident, bad surgery. Is why we need a self-driving car, haha. Okay. So recognizing objects now, not just shapes. We have cars, road, barriers. In reinforcement learning, tasks... in reinforcement learning tasks, nodes work in a bit of a different way. All data is initially unspecified, and your task is to recognize it and transmit it to RL agent, the AI. So SIFT can do object detection. It's the unrecognized data on the input and classifies them as either an object or as a road. Objects go to the upper socket, roads to the bottom, in this example. Roads. Where we're going. In the real world, SIFT, one of the most powerful, this is the same thing it had before. Or SIFT. Okay. So, one of this. What are we supposed to send here? Is it both things? And that way it learns which one is the road and which one's not road. Other objects. But they all end up here. I think. That's quick. Speed it up. Speed up the runtime of it. Okay. So is that good? I'm not sure. What does tune do? Supervised learning. On this screen, you'll be training and testing your AI. The AI acts basing on data you've been recognizing when building your scheme. So the environment goes into the car and then makes decisions on what to do. Gas, brake, drive, steer. The data about surroundings on the road are processed from your scheme to machine learning model. Your car won't be capable of learning and detecting obstacles without it. So our target average speed is 51 miles per hour. The goal in this type of task is to make the AI clever enough to be able to reach the target average speed level. Okay. Press supervised learning and drive the track yourself using WASD or arrow keys to teach the AI. Be careful the car sees only objects inside a LiDAR area, such as green, and only learns from those. So don't steer away too fast, sounds like. Supervised learning to proceed. Okay. Can I read this stuff first? Nope, I'm just right into it. Okay, so that's a car. Go faster. So see a car in front of us. Move over. Does it have to be fully in the area, do you think? There's another car. Press training and watch the car's AI trying to reproduce your actions. We hope you've been driving safely in that supervised learning stage. Okay. I still want to read this stuff. Or manually to record your actions. Pay attention to what your vehicle sees on the LiDARs. Launch training so the machine learning algorithm would try and reiterate your actions. When the car successfully achieves target speed, run the test. Okay. Training. Evolve. Auto-evolve. Your model has achieved the target speed. It was easy. Press test and enjoy your results. If the result isn't good enough, try training the car again. Test run. We're going 54. Whoa. Cool. We trained a self-driving car. How about that? Text recognition? We are aware that you are able to create a text recognition system based on the Rosenblatt perceptron. You need a similar system that would also be able to distinguish vowels from consonants. This task is simpler, but more accuracy is required. Okay. Recapture company. Deep news. Rosenblatt perceptron. The first perceptron, machine neuron, was invented by Frank Rosenblatt in 1957. Frank created Mark I in 1960. Mark I is a perceptron machine that can recognize English letters by their shapes. That's cool. So it would you could hold up a picture of the shape and it would learn it, or be able to accurately name it. So here's my problem. Wait, this will accept circles or triangles as okay. This will accept squares or triangles. So circles here, squares here, triangles can go to either one. So just, I guess, pick one. I need more stuff here. So we'll send the triangles here, I guess. Some triangles should make it through, and that'll be fine. Look up the input. Training? All right, so the perceptron will only get down to 20% failure rate, and then it'll tell me it's all done. Yep. Nothing more to teach them. So let's try a test run. Ooh, we're still above 75, but barely. Hey, cool. We did it. And we got a gold medal, even. All right. So now we could try a self-driving car startup. Hi! We are trying to launch our self-driving taxi service. It is Uber. It is a very promising startup, but we have a problem. Our algorithm makes a lot of errors when it tries to recognize traffic lights. As a result, the car sometimes moves instead of stopping. That doesn't seem good. We hope you can solve this problem. The code must be working very fast. About to invest 4,000 in the startup. What do I have? 91 something. Be nice if it showed it on this page without me having to squint at that. Sure you want to do this? Yes. You don't need to train your nodes while working on a startup. They already have the minimum error margin because time is money. Cool. So just one. Circles and squares here and triangles here. Yeah. A test run. Alright, this accuracy is not so great. But I guess it's getting better. I'm not sure how I could improve it except to put another perceptron with, again, sending everything but triangles this way. So it should be mostly triangles coming in, so 20% failure rate would be even less than 20% this. Would that work? Put another perceptron in here. Again, send anything we get except triangles that way. Speed it up a bit. We're getting no triangles down here yet. But I think that'll do it, right? Just adding more perceptrons made it more accurate. Okay, I think we release it. This action deploys the code to the servers. From this moment, the startup will work automatically. Launch. It's not always possible to satisfy all your customers in one day. Users with unfulfilled requests are shown in red. You don't have the instruments to solve this problem for the startup, but you'll get some to handle the future ones. Okay. All right, so I invested 4,000. As long as it's above that, I guess we're good. So that's going. Parallel calculations. This is about load balancing. Scientific Center. Hello, we represent a scientific center. Our current programs are underperforming. Can you parallelize our calculations? Ooh, balancer. Servers. To process data, your nodes need computing power. A server. Certain nodes require more than one server. The more servers you use, the more expensive your scheme becomes. Okay. Yep. This node routes elements to the least overloaded socket. Warning, this node requires an additional server power. In the real world, a load balancer is a device that distributes network or application traffic across a cluster of servers. Load balancing improves responsiveness and increases the availability of applications. Like software. Basically, send half of it each way. Test run. Oh, it sent them all at the same time. Let's slow it down and watch this. Shoo. Cool. All right. So we're making bank. Let me see how my startup's doing. Ooh, our income went down. Okay. Do we want to do a side quest with basic machine learning, or do we want to go to large parallel calculations? Let's try side quest. I keep trying these and going, that's complicated. Christmas shop, hey, 'tis the season. Good afternoon. We've just bought a stock of trees for the holidays. Friends say that you can calculate the peak demand period for them. Please help us. So send yellow this way. All right, so the decision trees work as... So red will always come out the top. Blue will always come out the bottom. Yellow could be on either one. So they only want one decision. They only want one node. But I have to get some to here. So let's say yellow always comes off the bottom. How do I get red and blue only to here? Can't hook you up to your... I can hook the output to the input. That's not that helpful, but... Red and blue. Red, green. This one did... There's no yellow in this one. Is there? Oh. RG, GB, gold. They're calling it gold, not yellow. So red and gold, blue and gold, yellow and red. That won't help me either. They only want yellow down here. And we have to fulfill that to make them happy. So I still think we need to send yellow this way. Red this way. Some blue will make it through here, though. If it gets randomly output. But we're only allowed to have one node. I don't know how to, with one node. I mean, that worked. Sure. But if I do another test run and it puts blue randomly ahead? See, it keeps failing. It keeps coming out successful right before the blue hits down here. So I mean, that worked, but it shouldn't have. And it will fail eventually. I guess we go ahead and let it run, and then just let it pass. Hey, side quest done. Okay. We'll accept that $1,000. How's our day going here? Okay. Ancient artifact. Not Loki at cat.meow. Good day. Our group is working on finding an ancient artifact called Tesseract. It's a very unstable element which radiates energy in different specters. Spectrums? We have almost found out how to use its power to benefit humankind, but we need a smart algorithm that will separate and direct flows of energy correctly. Revolution in energetics is just around the corner, my friend. Okay. Yikes. So we get three nodes, balancer, decision tree, and a trash can. I think this would count as a node, right? Two parallel. Yeah. Which is the same as just this. If we do a balancer, and then two decision trees, we could say basically red comes out the bottom and I don't know, blue here, and gold could go either way, and that's fine. Actually, blue can come out here too. That's weird. So we've got anything, red and blue, or gold and blue. So blue is the one that we most... Blue can go to any of them. So we should be filtering like red and yellow, maybe. Their decision trees. So yellow here. Red? Here. I should also look at the number of things. I mean, I think this will do it. Let's see. That's a lot of stuff. That's cool to watch. Okay. So, success. So far, oh, our income went up. Nice. Our hype is gray, which means we're losing people. I forget what they said gray means. And new production. The best clothes. Top of the morning to you from Zimoletto Outfits. We're trying to optimize our production lines, and we need a system that would distribute textile by material and send into respective conveyors in equal amounts. We believe you could nail this job, so we look forward to hearing back from you. Okay. So everything but squares here. We've got decision trees and a balancer. We get 4 objects. So we could send everything through a balancer, I guess. We want to make sure only circles go up. Squares have to go, well, squares, only squares go, wait. I can do an anything? Because what do I do if it gets a triangle? It'll split randomly. So that should be fine. If I say square here, because we definitely don't want squares there, so definitely put all squares in this one. And if we say circles here, you won't get any circles here, but you'll get triangles randomly to either one. That seems legitimate. And here, we can put any to either of them. So just another balancer, split it. This will bring all of our inputs in, split them evenly here. Stuff will all go. That should work. All right, that one's getting super backed up. I'm gonna run out of time. Yeah, see, we're down to a bronze medal. All right, so that is very slow. Pretty much, we want to filter out, we want to make sure no squares go here. Everything else can get everything else. We're not going to get any triangles here. That's weird. And these circles. Let's delete all that. What if we send all the circles and squares here? There won't be any triangles, and that should be fine. Oh. I think I see what to do. Circles and triangles go this way. Oh, but we'll get squares. We don't want squares at all. We want squares to go here. That's the only one we actually care about. But I was thinking if we put two load balancers here, split it in half, have half of it go there, and have these go like this. That is different from what I did last time, right? Because before I combined these into a balancer and then re-split it out. Alright, so those are both satisfied. Just we're gonna run out of time on the top one again. Yeah. There's no silver. You either get gold or bronze on this one. Alright, it was a little bit better. Still just kind of slow, though. What if I do 2 decision trees? And split the work between them evenly? Well, these can accept anything, though. So, time-wise, oh, because I want to get more shapes up there is the only reason to use another one of these. And balance this output between the 2 of these. So some circles will go up there. And if we balance ahead of this decision tree and this decision tree can split the work between them. That's pretty slow. Yeah, that's not going to do it either. Yeah, not even close. If I shove everything through one load balancer, I don't know, this is another tricky side quest. So what if is our income? See, made some money. So we invested 4,000, so we've made 132 so far. Instead of banging our head against the wall on side quests, let's move forward again. Just to learn a few more things here. Large parallel calculations. Hey, our parallelization system broke after the last Doors OS upgrade. Not Windows, Doors. Can you fix it? It is a very big system, be careful. Ah, deep news. The darkest years of machine learning. In 1969, Seymour Papert and Marvin Lee Minsky wrote a book called Perceptrons. In this book, they spoke about math constraints of the first perceptrons, the XOR problem. This book has shifted the scientific interest and funds distribution from the US government organizations, slowing down the progression of machine learning for almost 30 years. The expanded version of the book was released in 1987, containing chapters that disproved the statements from the critical remarks made since 1969. Huh. Oh. Do you just need rebalancers? Split the work. That's cool to watch, though, isn't it? We're good. Yeah, these mainline ones are often pretty easy. Let's check another side quest here. Secret information. No text here? Good day to you. We are a secret military organization. Our code name is Protoss. Everything you are going to read further is classified. Our analysts are sending operatives to various war zones An escalation of conflict with the enemy has recently occurred. We are in need of self-learning algorithm. A self-learning algorithm capable of sending dedicated units to respective parts of the battlefield. So everybody, oh. Yellow this way. We need, okay. There's only 8 blue. So it might be worth just saying, send all the red this way, everything else this way. We say yellow, some blue will go that way, and that's fine. Sorry, I said yellow. I meant some blue will go this way. Is that all we need? So all yellow will go this way, all red will go this way, some blue will go either way. And we could put another one of these and a balancer, I think. Let's test this and see how it goes. Yeah, see, it's not getting overloaded. It's sending a whole lot of stuff to the top that it doesn't need. This is taking forever. Wait, did it run out? Did it not hit 90? I think it did. So what if we send half the red here and half the red there with a balancer? So that would send more, but all the yellow this way. And then it would randomly split the red and blues that come out the top. I guess not randomly, but evenly split them. Silver medal, that's not bad. I'll take it. Release the code. Cyber initiative. Oh wait, before I get there, startup still good? Startup still good. Cyber initiative. Greetings. Our company, Cyber Initiative, is into manufacturing androids. Our production lines are fully robotized. The only function which is still performed by human workers is logistics. We're shipping our androids to the government, military companies, etc. We would like to automate this process with an algorithm that will distribute androids depending on their characteristics. Glory to the robots. Okay. So red and everything else kind of thing going on there. Actually, all the yellows have to go up. So let's filter out the yellows. So we can't have any of those down here. Red and blue can come down here. All the reds need to go here, all the blues need to go here. There won't be any yellows because those all got filtered out already. And I think in order to meet the demands of what we need to output up here, we could also put another balancer. Nice scroll sideways. I was thinking if we put another balancer in front, have some of it bypass like that, then more stuff will end up here. Yeah, that expert system is slow, but maybe not too slow. Yeah, this isn't going to get what it needs. Ran out of time. All right. What if we did decision tree based on color? The yellows go up. Reds go down. And some blue will make it through either way. So this will be red and blue. Only send red here and only blue there. I think that's similar to what we had before. Only yellows up. And balance these. This. I still think this one's probably not going to get enough. Yeah. We got way too much stuff in the bottom part. Not enough up top. So how do I balance more stuff this way? Maybe I do it like this instead. Wait. That'll get some yellow down here though, which is not what I want. That's not going to be great either. No, I'm just throwing stuff at the problem. Yellow here. Blue. Shut to red. So that should only be red. No. That won't even be accurate. I don't know. We'll come back to that one again some other time. We're making the bucks. What's available now? Increases node's work speed. Okay. Increases socket processing queue. DLL slots. That looked interesting. That was a new thing. New cat skin. Google glasses. What else was there? Increase node work speed. Kel server. Decreases server costs. This would be kind of good to get. I've got the cache for it, jeez. Decrease server costs, increase sockets, processing queue. Increases nodes work speed. Okay, let's continue on with the main line here. Dictatorship. Best dictator in the world. Greetings! This is the only state internet provider of a small country. We have a rather suboptimal code to track our people's activities. Unfortunately, we cannot allow you to change the actual code, but we have several new servers purchased on a garage sale. Parallel the calculations, this will help our tyranny prosper. Do I have to? These are CatHub repositories. They store previously made schemes and allow switching between them when required. You can choose a version of the scheme which will be used as custom node. Do I look in here? Oh. What am I doing? So it looks like we just need an expert system in here. I'm not sure why they introduced this. Just red goes in, everything else goes to the trash. We needed to go faster than this, don't we? Yeah. So, parallelize it. So we have multiples of this going on. We have two of them. Red into the output, this into the trash. Should go faster this way, right? Seven, 6, 5, 4, 3, 2, 1. Okay. Let's do like 4 of them. If you see where I'm going with this. Balancer. Another balancer. Let's just zoom out. Jeez. This will split the load this way. We'll have 2 expert systems in each direction. The red here. That goes into trash. Red there. And another expert system here. Red there, trash there. All right, so they're getting overloaded. Speed it up a little bit. Almost make it. Made it. Hooray for dictatorships. I do not promote dictatorships. Just put that out there. How's this startup doing? Another payday? Sweet. So do we want to look into another startup? Tatari. Good day! We're inviting you to join our hacker startup. We write cheats and guides for different games. Oh, gotcha. But now we would like to try making something really cool. We need a program that will play and win in Arachnoid instead of the player. We know that you know a lot about machine learning, so we're inviting you to participate in our startup. Invest 1,200? Sure. So... welcome back, Wally. So I think we need a couple decision trees in the output. And a trash can in the middle. So, red will go up. Blue will come down. And then blue will come down. Red will go up. Yellow, go into the trash. Yellow, go into the trash. That seems pretty good. It's not very expensive. So I guess release. So we got 2 startups going. Let's go ahead and work on... we got our self-driving car startup going. Tatari's going. Prediction of elections. Basic machine learning. Yahoo's Corp. Prediction of presidential elections. Good morning. We are contacting you on behalf of Yahoo's Corp. The president of our partner venture has been dismissed last month, and the board of directors is in the process of electing a new one. We need to be able to predict who will win the elections so we could make a decision about the future of our partnership with said venture. Make it happen, and you will get a handsome reward. Use Control-C to copy, Control-V to paste. Nice. Click, hold, and drag your mouse to select multiple nodes. Programming is easy, sometimes at least. We only want red. But it looks like we're going to need to do decision trees, and we have 17 seconds to get everything through. So if we do red and say blue, that'll always put blue out the bottom, blue or yellow. I'm gonna just trash that output. Sometimes red and yellow will come out the top. So we need to filter the yellow out. Have it also go to the trash. And then split the red here, here, and here. It should work, right? It's just whether it's fast enough to beat the time there. We only need 8 in each. We might want a second one of these going. Yeah, it didn't quite make it. We got the red. I think we could make it better. So here's where we can copy the whole thing. Copy this whole part, anyway. Copy. And paste. Oops. And then, just for the fun of it, clear this. put another balancer in front to split the work evenly. That should work basically twice as fast. 2, 1. Nope. We got gold that time. Okay. So we just made the time there, and we used exactly the number of nodes. Nice. All right, the market is always changing. Your scheme is failing to process all the incoming requests here. Try parallelizing your calculations. Sometimes the clients are flooding your place and you'll need more servers to process their orders. And sometimes there's but a handful of people and extra servers will only be wasting your funds. Pay attention to the numbers, experiment, and adapt. So let's do a patch for here. So wait, what happens if I switch here? I'm still not sure I quite get this. Like, can I copy paste this over? And have this be like my second version? I think it's just maybe a way to try out different things. So I keep activating things. So if we parallelize this again, I select that, move them, also copy and paste. I kind of like the way that looks. Put a balancer in front of it. So that should be twice as fast, right? I suppose I could also copy this all again. And make it even faster. Maybe that's as far out as I can zoom. Paste. Yikes. Starting to look real good and complex here. So balancer there, balancer here. This is where I'm not really calculating the benefits and costs of adding all this extra hardware. Go! Go, my pretty boxes, go. I know, but it's fun to watch, isn't it? Gotta go fast. All right, patch and launch. So we had like 20 users that weren't able to be served. Now we're down to, the numbers are going up, and it's not because, no, we didn't. We're not making anyone unhappy. What's going on here? Private message. Machine learning will help the animals. American scientists managed to develop a computer method for detecting the toxicity of chemicals, which is more accurate than animal testing. Nice. To create it, they used binary similarity coefficients. And the system itself was trained on information about more than 866,000 dangerous properties of chemicals commonly used in different experiments. Interesting. All right, so we're still making money on both of these ventures. So the self-driving car paycheck, we got 2,600 there. And I forget what we invested, 1,200 here. So we've already made that back. Cool. Oh, and another startup we could start for a tracking system. Oh, legitimate ruler. So this is our dictatorship again. Dissident-friendly tracking system. Flourish and prosper, respected programmer. We represent our glorious democratic leader, Admiral General President Ali Baboon Petrov Bashi. In his infinite wisdom, he offers/orders you to create a system that would process the recordings of kitchen talks of our beloved government critics, so they would be sent to our country's famous recreational camps. We will pay you a share from each individual who joins our national healthcare program too. One last detail, you must only use technologies developed in our country, as we despise your Western technologies and wish you all slow and painful death. Have a nice day. Sure. Oh. Okay. So this is like one of the problems we had before. Let's see. We skipped out on that one. So we only want circles. First of all. Everything else can go into the trash. Then, of those circles, I think we want a three-way decision tree. So red's up, yellow's down, and then an additional red, blue, yellow, blue. So only circles are coming through. Reds go up, yellows come down, and blues all go into the trash. I guess it's just then a matter of whether it's fast enough. That's one of those cases where we'll have to watch the numbers, I guess. I mean, it solves the problem. All that hype, huh? Ooh, not fast enough, looks like. Maybe. So let's parallelize it. Some balancers in here. Copy, paste. And maybe even one more. Like that. Copy and paste down here. Whoops. Whoops. Unselect. Move these trash cans right here. Move this entire row. All of these over to here. Oops, grabbed one of those. Just making room for the balancers in here. So I'll like this and scooch them over real close. Then we got the sift algorithms. We'll have balancer, balancer, balancer again. Because we were way underperforming on that first day. We don't want the hype to lose us our customers. All right, so this is faster, I think. Patch and go. All right, so we handled it much better. We still lost money. All right, and these are still doing pretty good. Let's keep going. Oh, automatic movie rater. Side quest. Oscar committee. Oscars. Hello, this message is from the Oscar committee. We want to replace some of our experts with a neural network. Please design a system that could rate movies by their type. Thank you. So 14 seconds, 4 machines. I feel like we want... We definitely don't want blue here, and we definitely don't want yellow here. A whole lot of red. We only want 15 here and 30 here. So what if we sent all our yellows here? If we pick out blues, some red will go here, some red will go here, all the blues will come here. Is that fast enough? Nope, not fast enough. Let's do copy, paste, and balancer. Yeah, the top one is getting a ton. At that time, we got a silver. Would it be faster to add more balancers? That's good enough. Let's just accept the win. Check on our startups. Yikes. I really can't. I don't think I could fit any more stuff in here. We're just losing money on this. Maybe I just cash out and leave. I don't know. Let's ride it out, I guess. Heritage protection. National Heritage Protection System. Good morning. We have dozens of scientific equipment placed in protected areas for the sake of looking after the objects of natural heritage. We're parsing info from our equipment on a daily basis and need to sort it depending on the color of the report. Can you make a program that'll help us? Probably. Yeah. This one seems easy. Like, too easy. So we have... This is what we just did in our startup, right? Red, 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 blue, blue, blue. Change both of these middle ones to yellow. Go yellow, yellow. Should be it. Ta-da! That was easy. I like the easy ones, especially when they give me a lot of money. Okay. We're still losing money, but not as much. Hey, we can get new stuff. Ooh, new hardware. Increase data transfer speed by 5%. Sure. Nodes work speed. I still don't know what the DLL slots are for. I feel like I should hold off on that for now, I guess. Node work speed and data transfer speed. Node work sockets processing queue by 7. Sure. And let's get this, I guess. Probably have enough for this too. Yep. Let's just do that. Hopefully I don't lose so much money that I go in the hole. All right, this startup is starting to trail off. So we're gonna want to cash out pretty soon, it looks like. Still something I can get. Messy hairstyle, true classic. All right, Gamazon. Predicting the sales. Predicting the amount of sales for a clothing store. I have a clothing store. I want to see how much money I might earn during the holiday sales. Help me! Okay. Okay, so this looks almost like the other one. Red will go up and up. So we only get... So all the reds will go this way. This could be blue or yellow. This... Only yellow should get through to this. We'll hook yellow up to that. Actually, no. Yeah. So this will be blue or yellow. This will definitely be yellow. Back this up. We only want blue going down, yellow going up. So I feel like we want the blue to be load balanced between these two. And we want a load balancer for yellow going to here and here. Like that. So the red will just go up, and that'll be done pretty quickly. With a bronze. So I wouldn't make as much money. I mean, I spent 126. If I do it faster, I could get a better metal, but I think I would lose more money by adding balancers and more machines, right? Of course, it's only this that I would have to duplicate. Paste down this way. And just add one more balancer here. What did I spend? Like 126? That's nuts. Still bronze. And I spent 160. So let's go back. Undo, 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 undo. Did I just double undo? That was it. Speed it up. So we'll get a bronze, but... Oh, I guess making it take longer costs more. This came out okay. Good enough. You never ship the code. Alright, let's get out of this. Sell. Probably should get out of this too. We'll see how that goes. Let's do maybe one or two more. We could start another startup here. I own a small online bookstore. I need your help in choosing logistics company depending on a client's region and type of book ordered. I would love to automate the process with the help of a special program. I offer you a share of sales made with the help of your system. Please note that the entire data needs to be processed. Investing, it's only 500. Oh, geez. Could I bow out? This looks nuts. So we'd sort reds one way, have triangles coming down here and everything else going there. We'd sort gold. Well, all blue can just go straight through. And all gold would have to come out and then be sorted by squares. Some squares this way, all triangles this way, some squares and some circles this way. I'm gonna... It's in development, cool. I don't have to do that one. What do you got? Amazon. Alright, let's just continue up. Accuracy. Need harder machine learning job. Level up, maybe? Hi friends, it's me again. Thanks for those jobs. I can now afford a meal almost daily, but I need a kick-butt video card to proceed with my task. Ergo, need more monies. Am I ready for a more hardcore job, maybe? Look, coders grow up so fast. No problemo, my duderino. I'll send some more contracts your way with bigger data too. Beware, in these tasks you're allowed to make some mistakes, but they're way more tricky to crack. How so? This is real-life data science for you. Corrupted data, incorrect data, useless data. When it comes to big numbers, it's not about being 100% correct. It's about getting the job done, sonny. So we only need to be 50% accurate. And I only get the one decision tree. Alright, so red up, yellow down. Some mistakes will get through. But the blue will go out randomly. And there's way more of the other colors in this. So. Made it. Cool. Raging birds. Big data equals big mess. Okay. We're almost halfway to our cat speech recognition system. That's awesome. Let's not do side quests. Solvency assessment. Client solvency assessment. We represent the Moneybag Bank. We want you to create a system for sorting candidates applying for loans. We believe that cold, soulless mind of a machine will help us save more money than our regular, empathy-corrupted human clerks. We would very much appreciate it if you complete the task before the holidays. Letter from a friend. BFF. Hey, what's up, buddy? How are you? Listen, I know I wasn't paying you for quite a long time, and I'm very grateful that you weren't demanding for a paycheck for so long. But to be in debt, even to a friend, is not cool at all, right? Therefore, take this money you've honestly earned. Thank you, friend. You've really helped me out. Yeah. And how about we go to a concert next week? I almost feel like I'm playing No Time to Relax. A game that I played with Wally and Lana. I think Ontario played with us. You know, get a job, buy food, get some education. All right, so let's work for the bank. Deep news. Semi-supervised learning. Semi-supervised learning is used on partially unlabeled data with unknown answers. So some of it's labeled, some of it isn't. Typically, a machine learning model predicts answers for unlabeled data and uses prediction to improve. This method can improve quality of the model even when the data is not completely reliable. In real life, adding 5 to 10% of unlabeled data leads to minor quality improvement, and adding more data of this type spoils the model. I need 41 and 3. So if we have 2 of these, I need a higher percentage of accuracy on this. Let's do red, red, and send everything else down. I mean, yellow. Let's send all the blues this way because it has a... There's only 10 blues. So if any blues make it through here, it'll be a lot easier to mess up the red's accuracy. So we'll send all the yellow and blue here, and the 40 yellow should overwhelm the blues that'll get through. Ooh, come on, yellow. Sweet. Making money. Alright, so this made me money. This lost me money. Jeez. So does that go down? And Gamazon is still in development. Alright, almost machine learning. Your computer specialist, you gotta help me. I own a miniature pig farm and also have a crazy neighbor. He enjoys making bird-shaped shells out of paper mache and then throwing them at my piggy's sheds. He makes all kinds of shells, tiny red round ones, triangular and square ones, you name it. I'm constantly rebuilding my sheds so they would be impenetrable by those birds, but I need to be able to know the shapes of shells that Wacko's using. Can you please write an algorithm for that? Okay. So we're gonna have 7 nodes. Trying to think how I would split this up. So we've got triangle, 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 square, 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 circle, circle, circle. And we need a whole lot more of these. So maybe we send all the triangles here? We have triangle and else. Triangles here. Everything else can come up this way. And then we want to basically balance so send some stuff this way, some stuff this way, balance a little more that way, and some this way, and split this like this. The output of this. That work? So all of our triangles come down here. Everything else will get split evenly. And then these will send. Alright, night, Wally. Yeah, I'm almost done for the night too, I think. But the way these are splitting it, only 1, 2, 3, 4. Like only a quarter of it's going here. But it's mostly going to these and these. See how this goes. Oh, this only needs 90% accuracy though. It's weird. This is not gonna cut it, is it? Actually, I've got 2 going into here and only 1 going into here. What if I just remove this load balancer? Send all of that here. Will that work? That's not going to work at all. We're going to have 7 machines. This was a mainline task? Yeah. So our number of users is still going up, but our income is all over the place on this. That's bad. I'll just leave. Stop worrying about that one. What can I get? Decreases server costs, increase data transfer speed. I don't know. Let's try a side, see what this side quest looks like. I didn't even read that. Well, this will be yellow up, blue down. Any reds that make it through is fine. parallelizers, so I don't see how I can make that better. Unless I send more reds this way. Will that work? Didn't get enough up top. What's our options? Any? We could turn this into a kind of a splitter. Only blue this way and any goes up. Wait, if it matches both, so it's blue and any, some blues will come this way, won't they? Or is that not right? Yeah, some blues are going to come up this way. So we need to set this to red. But it needs some reds down below. Wait, we get 40? I thought I said 3 before, or something like that. What if we send the reds from this one down? No. So what did it do? Can we use another one basically as a balancer? If we put red and red. So it's a slow balancer. But it'll be a randomized balancer instead of a straight balancer. That worked. It's only a silver, but it worked. I'll take it. Color business. Good day. We've developed an innovative printing machine that allows us to apply complex patterns. As 2 print heads, it speeds up the process a lot, but the distribution of colors does not work for us. As a printing algorithm doesn't recognize them very well, we need to solve the problem before releasing novelty in the market. Okay, so we have 6. So we want all blues to go to the second half. We want all gold to end up here. We want yellow definitely here. We want red to go up. There'll be some... So wait, if we do red and yellow, red and blue here, some yellow will also come out here. All the reds will go up, all the blues will come down. Yellow and red. This will definitely be only blue down here. If we do yellow up this way. I want to split the blues. Here and here. I think we want to split the reds, like we did in the last one. So red and red. To go here and here. And both of these feed into here. So blue and yellow will come down. Blue will come down here and be split between these. Yellow will go here. Red and yellow will go up here. Yellow will go here. Red will come down here and then be split between these. That first decision tree is getting overloaded. I think I know a way I could fix that. Ran out of time. So if I feed... I have this here, and this one here. We could feed these the same way. So if this red output go to the same as that, this blue output go to the same as that. That way this first one was getting overwhelmed, now it's not. So maybe gold? Oh, we didn't get enough blue. That's a bummer. So maybe we don't split the blue. Will that work? Will there be enough red to fill that middle one? Nope. Why did this one just stop? Oh, I didn't have any output. Yeah, we need some of the blues to go here. I mean, I could put another decider to split one of these, but I don't know if that would be that great either. Something like that. I have a feeling this is not going to work either. We're sending a whole lot of reds up here, and we may only need the yellows up here. We only need 5 reds this way. So we only have 30 yellows. We need at least 5 reds in here. But I can't really control that much. Why would we want a trash can, you think? We definitely need reds in here because we won't be able to split the blues evenly. We only have 73. So we can't just send only the blue here. We need most of the reds here. How do I send most of the reds here? I don't think that'll make a difference. It's still sending a lot of red to the top one. We're short just a little bit on this one. By 2. All right. Well, it's a little bit of a anticlimactic ending here, but I think it's time to move on. I think it's time to call it a night. My brain's getting tired trying to solve these puzzles, and it's going on midnight here. So let me see who's on. Let's see. Looks like Sui is playing Pushonomics. It's like a potion brewing game. Looks like. Yeah, good night, Parawedding Worm. Gonna do a raid. Let's see. Today's Monday. Today's the last Monday of December. So next Monday will be in the new year. Awesome. Wednesday will be Factorio. The usual games. Shenanigans on Sunday, hopefully. Although that'll be New Year's Day, so I don't know. In the meantime, though, thanks for hanging out. Check out my YouTube. Leave comments and stuff if there's something you want to see more of or whatever. And I'm open to feedback. In the meantime, remember to be kind, have fun, and I'll see y'all later. Bye.